Hi, pal. Tony Lockwood here. I'm in Cleveland. Rock and Roll Hall of Fame is right over there on the other side of the windows. They didn't let me in there because of that. Well, I won't tell you about that KISS concert. Anyway, I'm here at the CAASE conference. This is a terrific event co-sponsored by Digital Engineering and by the NAFEMS organization. I have two interesting individuals here across from me, and I'm going to ask you to introduce yourselves and your company, and why should simulation using engineers care about what you guys are up to?
Well, thanks, Tony. Thanks for having us. So I'm Mach. I'm the founder of TotalCAE, and what we basically do is we provide hybrid HPC solutions to customers. So they need to speed up their simulations, kind of a common issue. Hey, I need to get my results faster, and that usually is done by adopting high-performance computing. So that has been a barrier for many years. Talk about democratization, that people couldn't access HPC because it's very difficult to adopt. Maybe their IT doesn't know how to adopt it. And now we have public cloud as well on top of that. So our company basically makes it very easy to adopt HPC, and as well as cloud, either on-prem, and we give you a simple user interface. So you just give us your simulation model, you push a button, and then it emails you, you get the results back. And everything that happens in between those two things, all that black magic, is what our company does. Right. So we're full service, and we just make it very easy for customers who want to get their models back faster, just basically outsource it to us, and we'll take care of everything for you. You don't have to do anything.
And I'm Antonio Guglielmetti. I head up our sales team at TotalCAE, and I'm really driving the adoption of our platform into a hybrid HPC environment.
Okay, explain what you mean by hybrid.
So historically what would happen is you would always have on-premise hardware, and we would manage that for you in your data center, and but your capacity was constrained to what you purchased. So if you had 100 CPUs, that's all you could use. But today what we see with the adoption of cloud is that you can use that 100 CPUs for your day-to-day engineering simulation, but let's say you have a big design that you need, and you need 1,000 CPUs. Well, the lead time to purchase that might be difficult, and maybe you don't need 1,000 CPUs because you're only using it for a month to do some front-end simulation of some sort. Well, now you can rent basically that CPU power on the public cloud, which we provide. So using the same exact interface and everything you already know, you just point your browser to a different location, and suddenly you have access to unlimited amount of hardware capability.
Okay.
And so that's what we mean by hybrid. You can do all your day-to-day engineering with its cheapest, fastest, simplest on-premise, and then when you need extra horsepower, you can always go to the public cloud that we offer to run those same.
So it's on demand.
Yeah, on demand. Exactly.
So I can have a burst capacity.
Yes,
that's right. I got a big honking.
Exactly. The beauty too is it's all driven through our platform, right? So whether it's on-premise or in the cloud, the users are still using the same tools, so it looks the same to the end user. There's no change in workflow or in their end tools, but we just forward that to the cloud for the short-term peak usages. It's great for pre-sales activities, trying to win business, and a lot of times our customers will win a business on the cloud, and then they actually bring that in-house because they can justify bringing that resource back in, and it's cheaper in the long term.
Right. Yeah. Okay, now my company relies on ANSYS.
Yes.
And you're ANSYS.
Yes, we're a partner with ANSYS, so we make an HPC appliance that you can put on-prem that's all managed by us, and then you get access to the public cloud with that. So then if you have extra capacity and you have in ANSYS's world, they have these HPC packs that unlock more cores. If you have that, then we can utilize that to run use all your licensing on the public cloud if you have need to burst or need extra capacity.
Okay, what I was wondering there is, okay, I gotta up my in-house power. Okay, I like this idea that I can burst up there when I need to do it. How do I know what I need day to day? Do you guys help me? Do you have suggested configurations? You try to figure out what.
Yeah, we have a standard best practice templates for ANSYS, for example, and many other vendors. We work with about 50 different application vendors, but we have these best practice templates, and then we will benchmark typically the user's model and say, okay, we took you from maybe 2 days to 2 hours. how, now how much, based on the licensing you have and your goals of how much throughput you need, then we can right size a system that'll be your 90%. For 90% of the time, you'll get your answers. You don't have to wait on-prem. And then if you have like large stuff you run occasionally, that's what we would then. We don't have to have the perfect answer. Then we could always offload that temporarily.
Right. Yeah. Typically, we spec it to the amount of licensing as well. We're trying to optimize licensing, the people costs, all of that, and we actually have a product to an analyzer product that shows the utilization of the cluster, the licensing. So after the fact, after our platform's installed, maybe in year one, at the end of the year one, you can see what was used and the utilization of the licenses.
Right, you need more. You're buying too much.
Yes,
right.
Yeah. Because a lot of the times the engineer feels like I need more stuff. I need more stuff, but without data, without the data, it's hard to prove. So we provide all the data analytics so that they can go to their management with a graph that's all pre-done and says, look, I was waiting all the time, for a year, and I didn't have enough licensing half the time. And maybe a lot of times they might have enough hardware, just not enough licensing, and that those tools help them like make the justification
and figure it all out
and sell it better than some customers going on decades where we are the folks that handle all this for them. So,
very good. And so if you try to the cost of it, you try to obviously make it affordable to them.
Yes.
The software licensing, that's another
the software
story,
they typically still buy from their ISV,
right.
But the management is we have a small business plan, an enterprise plan, and it's a fixed cost, and every month we try to win their business, so we don't, we try to make it...
Every month?
Yeah, every month we can win their business, so we call it the non-cable model. We're here to win their business. We want customers choose to be with us, not that they feel like that they have to be with us, and so we have very good service, and and that's why we strive to keep our customers month to month. Our engineer is our customer, so that's why they like having somebody who's almost their ambassador to help them get their job done. That's who we are.
Yeah, it's very good. Do you have functionality that helps the engineer? How, especially in the early days. Okay, how many cores do you want to use? I don't know. I don't know.
So
you help them out with that?
Our tools. A lot of times the choice on how many cores is based around the licensing. So our platform automatically will calculate how many licenses you need to run a job, and then you can see in the platform how many you have available. So sometimes an engineer will say, well, even though right now I could run a 14 CPU job and it'll run right now. Right. So I'd just rather run right now, and that gives you all that data right there to make the decision, and you can select 14 cores and push the button. So so we do help customers though to say the most optimal core count based on your licensing and everything is this, and then they can, and then we try to strive to have them submit that core count all the time, because if you do it over a lot of period of time, you can get the most dollar value of your software license, which is the most expensive part of all of this. Is typically the engineering application. So, so sometimes the customer will do that, sometimes not. But we do help them identify what is the sweet spot as part of our
that's
service.
the beginning, like the benchmark phase is what is the optimal throughput? Because at the end of the day, you're trying to get the most jobs for the application.
Right, and get it all done as soon as you can.
Now, whether they choose to do that or not,
because sometimes you have the practical thing is I need this job to start right now. It's Friday at 5. I want to just make sure that it starts iterating. We give
them the perfect world scenario.
Yeah, very good. Are your customers asking you for more type of stuff? I don't know. Better ways to utilize your services or anything like that. What do you hear from them?
Yeah, the biggest trend that we've seen in the last, I'd say, 12 months, it's been increasing a lot, is the people really love the idea that they can occasionally run big design of experiments or larger models than they couldn't, but that they couldn't with their on-prem system. So in the old days, they might have to just wait, and the problem with sometimes waiting is maybe by the time you get the answer, you can't impact the design anymore. So now they like the idea that even though it's extremely expensive sometimes to rent compute power, but it's still, if it allows them to impact the design, that's what they really care
less
about.
Dumbing down the design as well,
instead
of things like that.
So we've had a lot where like, hey, we have to make a decision. We have one of our customers. we have to make a decision about the shape of this car. We need to know soon. And so even though they have lots of other projects, they're having queuing And they said, let's just go rent it. Let's get the answer right now. And so that is the biggest trend that a lot of our customers are extremely happy with that.
We provide them that ultimate flexibility, right?
Yeah.
So whether they want to run 2,000 cores in the cloud or run 500 on premise, it's still, again, all through our platform.
Yeah.
And you take care of all the
exactly.
hardware, you know, hey.
Yeah, typically from the end user perspective, the user knows I need to run, 2,000 cores and run it on the cloud, and they don't necessarily want to deal with all the intricacies of setting it up, but they just tell us the business objective, and then we provide the interface for them to just click.
Do it.
Yeah, click submit and get the job.
Yeah, that's the way.
And we help customers, because on the cloud you are paying, you're renting that compute time, so our platform gives them ideas of how much this job will cost you. It tells them before they submit, hey, it's going to cost this much, so maybe you should do your data check on premise.
Right.
Because if you make a mistake in the model, it is going to cost you so many dollars, and let's do that where it's free, and then, so we help them with those kind of workflows.
Yeah, that's good.
And I'd say the other trend that we've seen quite rapid is this rapid storage is extremely cheap, so customers are now having hundreds of terabytes as a pretty regular basis for the engineering data, and now they have the challenge of, I have hundreds of terabytes of engineering data.
What do I do with it?
What do I do with it? And
Right,
so we've been helping customers with tools to help them store and be able to retrieve and find and clean and manage that. So that's been a growing trend, that as storage has gotten so cheap, it almost isn't cost effective to pay an engineer to clean it up, but still we need to manage that data in some simple way.
Right.
And maybe not a full-blown PLM type system, but they need some kind of simple mechanism to manage their data.
Know where it is.
Yeah, know where it is.
Find it.
Help them organize it, and without necessarily having try to enforce some data organizations and so that's something that we've been doing a lot with, and we have some tools that help customers with that as well.
All right. Well, now I'm going to ask you to give us your website so that people can go to you and find out what's happening, and so why don't you look into that camera and tell them what it is.
Yeah, you can go to www.totalcae.com, and there's a Learn page. You can subscribe. We always have a lot of interesting topics for engineers around HPC, cloud, containers, lots of different things there that you can learn. Always have new content. So, totalcae.com.
And
thank you, Tony.
And that will be available if your manual word processor isn't working for you right now. You could always send an email to the DE editors, and we'll get you their details. Gentlemen, thank you so much.
Yeah, thank you for having us.
Stuff.
Yeah,
thank
you for having us.
Bye, pal.